As soon as we give power to this outdoor unit PCB, look at this, we powered it on. And now you can see that its D11 is flashing. It has started turning on and off, again and again. The indoor unit is not connected with it right now. I am only checking the outdoor unit separately. Now the sound from it has also stopped. The indoor unit is still not attached. I am just testing the outdoor PCB. This is a magnet PCB installed in a Panasonic unit. And this is the kind of problem it is showing. Now look, it has become a little better, and it is flashing again. Now I will turn it off. When I physically inspected this PCB, look here. This capacitor is swollen from the top. In fact, it is swollen so much that it looks like it is about to burst. Apart from this, look at these capacitors installed here. Almost all of them are swollen. So what happens when these capacitors swell is that they no longer function properly. And the result we are getting from this PCB appears because of this issue. All of these capacitors are installed almost around the SMPS section. These ones are for the DC supply, and I think these may be for AC, maybe, but I will have to check them properly. Now, we will remove all of these capacitors from here, because the first thing we need to do is replace or remove the physically damaged parts. Never continue fault tracing with physically damaged components still installed. First, remove them. If you do not remove them from the system, then you may not be able to trace the next fault properly. These capacitors are getting very hot, and they are also fitted very tightly. So I will hold this one by hand, heat it from the other side, and maybe it will come out. Look, it is very tight. Here it is. One capacitor has come out. I think almost all of these are 470 microfarad and 25 volt capacitors. This one is also 470 microfarad, 25 volt. Now, this capacitor here is not swollen, but should we change it or not? Okay, let's remove this one as well. This is also the same value. Okay, let's do it this way. This capacitor is not damaged, but we will still replace it because it is installed in the same section of the system, so it has become necessary to change it as well. Sometimes, when capacitors are installed in the same area, they can also develop problems. The electrolytes inside them can also dry out over time. Because of that, the performance can be affected. And if the complaint comes back again, then it will become a problem. This capacitor is not physically damaged, but it is a 220 microfarad, 35 volt capacitor. Now we have replaced the parts that were physically damaged. So let's give power to the PCB once and turn it on. I have turned it on, but the switching sound did not come from it yet. The switching sound should have come, and the relay sound also did not come. However, its D10 is blinking. Let's check how many times it is blinking. I will count it here. 1, 2, 3, 4, 5, 6, 7, 8. So D10 is blinking 8 times. D11 is behaving normally, which means the error may be related to a sensor or something similar. Now I will turn it off once. Now the relay made a sound while turning off, but it did not make a sound while turning on. So now it has turned off. This means the PCB is turning on, but it is weak. So we will give power to it once again. I have powered it on, and now the system has turned on. Now we will check the voltage here on the IPM. First, we will check it on negative and positive. I placed the probe on negative and now on positive. So we are getting 306 DC volts, which is okay. Now on U, we are getting 14.65 volts. That is fine. Let's check on V. On V, it is also the same. And now lastly on W, W is also the same. This means the rest of the system is behaving properly. Now we will check it and test it properly. But I feel there is an issue with this relay because its strength has become weak. It is switching but not properly. It should make a clear tuck sound when it switches on, but that is not happening. This means this relay has become weak. Now look, I have turned it off. Now you will hear the sound when it turns off. Look, this sound came now. The sound is coming when it turns off, but not when it turns on. So this relay has become weak. Its strength is low. For guarantee, so that the complaint does not come back, we will replace this relay. We will install this new relay in place of the old one. We will fit this relay here. Both relays are almost the same, and there is no issue with them. The only difference is that this relay does not have the two overhead terminals. This one is closed from the back, while the other one is not. The other relay has two overhead terminals as well, so we can take a connection from there. In this relay, we do not have that connection option, but the working of both relays is exactly the same. So we will install this one. Now I will give power to the PCB, and we will listen to the relay sound. This relay is switching very fast. As soon as we turn it on, it switches immediately. Now I have turned off the power. Look, it has turned off again, so the relay is switching very quickly. That is why I felt it might be faulty, but actually it is working properly. Still, even after this, we will leave this relay installed here. Now I have given power to the indoor unit, and the outdoor unit has turned on. Look, it's working at 16 degrees. The indoor fan motor has also started running. Since this PCB was showing an H11 error, we will quickly check whether the H11 error is still present in it or not. It does not seem like the error is still there. It looks like it has been fixed. But still, we will confirm it properly. So we will place one probe on neutral and the other probe on the communication wire. Look here, we are getting proper fluctuation. When this kind of fluctuation is present, normally it means the communication is okay. Now, during testing, as soon as I connected the system here, it was not starting the compressor. When the compressor did not start, I tried to get an error code from the system so that the work I need to do here would become easier. But the error code was also not appearing quickly. So I left the system running for 2 to 3 hours, thinking that maybe at some point it would show an error. Now I have tested its indoor and outdoor units very well, and I did not find any kind of fault in it. As I showed you, I left it running for more than an hour, but it didn't give any error, nor did it work. After that, I did a thorough testing of the outdoor unit, but I didn't see any fault in it. So after that, I thought that it is possible that there might be a fault in these sensors. Whenever this kind of repair job comes in, it becomes a major challenge for me. Because when work comes, there is a big issue with connectors, etc. And then I have to improvise, like this. But if you have original ones, the work gets done quickly. So look, I have joined them by using pins, etc. This becomes a bit of a long process. So to avoid this, I have kept proper complete sensors. Normally, these sensors do not belong to this PCB. And if you look at their connectors, see, I will take them out and show you. For these and this one, I have attached an extra wire and joined this sensor to it here. Regarding the other sensor, I arranged it in such a way. See, these connections are usually made easily, meaning in the PCBs that often come, this connector gets attached directly, which makes it very easy for me. Along with that, I have added 2 extra connectors. See, this became female and this became male. Similarly with the white one, I have also, attached 2 connectors so that whichever sensor comes, it is easy for me and I can quickly attach it and test the PCB. So this is what I have done. But for the black one, I could not find the system. So for now, it is single like this. Normally, it happens that white is joined with white. Along with this, when I had to decide for the yellow one, what I did was to attach the yellow one with the red one. Okay? Now, since this black one could not have a connector attached to it, I was forced to add an extra sensor, which I have added. But now, when I checked here, the red one, the red sensor, the sensor I had, see the red connector in it has a sensor attached to it, this one. So this sensor attaches to the compressor's discharge pipe. It means that its value at a minimum of 25 degrees is approximately 50 kiloohms. So I have attached it to this. The white sensor is for the outdoor temperature. The sensor I have has this attached to it. Now, this is where the mistake happened. So I will show you. Let's take out these sensors of it. Now, the yellow wire here is where the outdoor air temperature sensor, thermistor, is attached. Along with it, the white one is where the compressor temperature sensor, thermistor, is attached. And the black one is where the condenser pipe sensor is attached. So, what did I do? The black one was perfectly okay. There is no issue with it. The white one, I had attached the white one here. See, I attached the white one. While in my testing sensors, the white sensor is for the outdoor temperature. It means that its value is at most 6, 7, 8 kiloohms or not more than 10 kiloohms, but I think this is a 6 kiloohm sensor. And similarly, For the yellow one, the outdoor temperature sensor was supposed to be attached. So I had attached these sensors incorrectly. And on the yellow, I had attached the red one, and the red one was approximately 50 kilo ohms, which is why this problem was occurring. So now, let's fix this properly. See, I will attach this white one with the yellow one, and the white one here, I will attach it with the red one. Now, let's test this PCB again to see if it is working or not. So I will turn on the PCB. I turned on the electricity. See, the whole system has turned on. The display has started. Look, the outdoor unit has also started. Both its lights are working. The main LED, as well as the sensor LED, is also working. The switching has happened for the fan. So look, the compressor has started. See, it has started very well. Everything is perfectly fine, and our system here is also perfectly okay. But I won't run it for long because there is no heatsink here, so it might cause an issue. We will turn it off soon.
Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.